Hello everyone, I'm Huiyu from Meta AI. Today I'm going to talk about ego-only, egocentric action detection without exocentric transferring. This is a joint effort with Mitesh and Lorenzo. The primary goal of our research is to detect and categorize human actions in egocentric videos. Given a long input video, our model identifies temporal segments where specific human actions occur and classifies them into relevant categories. Existing approaches rely on exocentric pre-training that classify third-person videos with lots of labels. An example could be a transformer pre-trained on Kinetics 400. Then, this pre-trained model is fine-tuned on egocentric videos with much fewer temporal segments of actions. Finally, features are extracted from this fine-tuned model to power the last stage of egocentric action detector, such as an action former. There are also attempts to pre-train even more on large-scale image datasets, or adopt masked autoencoders to pre-train self-supervisedly before the model learns to classify exocentric videos. This line of research is based on previous observations that egocentric models can hardly be trained from scratch and that exocentric representation transfer to egocentric data. However, by looking at these examples from Ego4D and Kinetics, we noticed many challenges in egocentric videos. There is usually no actor in view, but more of hand-object interaction. There is also a domain shift in the activities performed. Egocentric actions are usually more fine-grained and thus long-tailed, with sometimes only a few samples per class. Egocentric videos are usually longer in duration and therefore require localizing the actions within the video of similar appearance rather than classifying between videos. These all make it challenging for exocentric representations to transfer to egocentric domain. In this work, we revisit this decision and propose an alternative approach called ego-only that trains models from scratch solely within the egocentric domain. It doesn't depend on any form of exocentric transferring. And surprisingly, ego-only performs better given the recent egocentric data collection efforts and the development of masked autoencoders. Our ego-only method has 3 stages. First, we simply take an off-the-shelf video MAE algorithm and pre-train on egocentric data. Next, the model is fine-tuned with a temporal segmentation objective, which is simply per frame classification with spatially pooled features. Finally, any existing action detector can be applied on top of the frozen features to produce temporal segments. In this way, we don't depend on exocentric transferring anymore, but can train our egocentric detector effectively. Empirically, our approach yielded surprisingly good results on detection and recognition tasks. For example, on Ego4D detection, our ego-only model consumes only 14K of egocentric labels, but outperforms other transferring methods that use 1,000 times more exocentric data. Similarly, on Charade's ego recognition, ego-only utilizes only 33K labeled segments, but matches Lavilla that was trained on massive scale vision language data, or EgoAxle that was designed specifically to distill knowledge from axle to ego. On Epikitchen's 100 action detection benchmark, ego-only outperforms action former by a large margin as well. We also benchmark ego-only on action recognition that allows us to compare with more established video models. Note that these state-of-the-art models might take hundreds of frames as input or train on huge datasets or exploit multimodal supervision or model long-term temporal context. Surprisingly, we found ego-only outperformed all these approaches in classifying verbs, probably thanks to the knowledge learned in the egocentric video MAE stage. At the same time, we notice that ego-only lags behind in classifying nouns, probably because existing solutions often pre-train on large image datasets with many more diverse objects. To further understand how ego-only learns, we visualize some MAE reconstruction results. The first row shows the original video of this person flattening the dough with a rolling pin. The second row visualizes the masked video with the default masking ratio of 90%. We can barely see the action of this person. In the last row, we show the prediction from video MAE that reconstructs the original action reasonably well. Furthermore, we found that due to the head motion happening in egocentric videos, MAE might have learned spatial temporal correspondence as it can reconstruct this scene with good temporal consistency. In summary, we have shown that state-of-the-art egocentric action detectors can be trained effectively without relying on exocentric data transfer. Ego-only is an order of magnitude more label efficient and improves results compared with previous state-of-the-art solutions. Thank you.